Assalamualaikum. We are group number 2 for the advanced electrical circuits assignment, where we are assigned for a high pass filter. So before I continue, I would like to introduce myself. My name is Muhammad Ruslimi bin Ismail, and this is my group member. So I will give an explanation about what is a high pass filter. High pass filter is an electronic filter that passes signals with a frequency higher than a certain cutoff frequency and attenuates or rejects signals with frequencies lower than the cutoff frequency. So as you can see, this is a basic circuit for a high pass filter where we have a capacitor that is connected in series with a resistor. Now we will look at the cutoff frequency of a high pass filter. Cutoff frequency of a high pass filter is when the frequency at which the amplitude of the output voltage is 0.707 of the maximum amplitude. And application for a high pass filter is to be used in speaker for amplification, to remove unwanted sounds, to prevent the amplification of DC current, and to enhance image processing. So that is all from me. I will pass to the next presenter. Thank you.
Assalamualaikum and good morning. My name is Muhammad Amir Hafizul Amzi from BEAS1. My matrix number is B0821102028. Today, I want to present about calculation that my group have made, which is high pass filter circuit. From from the assignment, we must find the derivative transfer function, provide the zero input, and calculate the frequency F0. And this is our calculation. From the circuit, we can get the S at C equal to 1 over J omega C and hash omega equal to V out for V in. Firstly, we must find the V out for V in using the VDR. And D is VDR. R over SC plus R multiply with V in. And we can get V out for V in from the equation. And this is V out over V in. And from this equation, we must change the IC with 1 over J omega C. And we can get R over J omega over C plus R. And we must multiply R with J omega C over J omega C. And we can get this equation. From this equation, we can get hash omega. And we can get h omega equal to rj omega c over 1 plus rj omega c. From this equation, we can get value of h0 and h infinity. And we need to change omega with 0 uh, from this equation. And we can get from h0 equal to 0 and h infinity equal to 1. From this value, we can conclude the filter is high pass due to hash 0 equal to 0 and hash infinity equal to 1. And and provide to 0 input. How to provide 0 input and what is 0 input? 0 is the numerator and pool is denominator. And we can get the value of 0 input from this equation. And from the equation, we can get 0 is 0 because they have no plus or minus in numerator. And the pole is 1 over RC. We can see in this denominator. And lastly, calculate the frequency of F naught. And we can get F naught equal to Fc equal to 1 over 2 pi RC. And we can get RC from this circuit. Uh, R equal to 1K, C equal to 1.5 mu F. And we can calculate the F naught. And we can get F naught equal to 318.330 Hertz. Thank you. That's all from me.
Muhammad Kishazwan bin Muhammad Amin. My material numbers is B 0821100032, and I came from BA S11. So for today, I want share to you guys about the high pass filter for measurement using a multisim. So let's go. I share to you guys. Okay, so I share screen. So okay, this is my circuit for high pass. So you can see this is a capacitor and this is a resistor. So I construct the circuit. Okay, this is a capacitor and this is a resistor. Okay, you guys can see. So yeah, so you guys can see. Okay, you guys can see. Can use a three amplitude, 3 VP, and one step from 100 frequency, 100 plus frequency. So, so 3 VP and from the 100. Okay, so I can get this. So for channel 1, measure channel 1 to and channel 2 to peak. Okay, channel value. So this is channel 2. See. So okay, so for this we can see for the 100 plus and amplitude 3 VP. So you can get so this to So we can get 917. So we can get 917 millivolt for the so get the 2.36. So maybe in 30 2.32. No, maybe 370.29. So no, 2.5355. So we can get still no. 0 but no. So still until we can get the V output is 2.12. Okay, so I can get, yes, for the 315 hertz, we can get the 3 V output is 2.12 for the FC frequency. So that's all for me. Thank you.
Okay, thank you for my group mate. Now, I, Muhammad Izzat Zakwami Muhammad Razmin, will talk about discussion and conclusion for this assignment. Okay, for the discussion, high pass filter circuit pass signal of the frequency higher than the cut-off frequency, while the low pass filter pass signal of the frequency lower than. For the construction of the circuit that given, we assign the value of the resistor as 1 kilo ohm, capacitor as 0.5 microfarad, and amplitude 3 Vp, and 100 Hz frequency for the starter. Then we connect the channel 1 of the Tronic oscilloscope to the V in, while the channel 2 to the V out of the circuit. Here the picture of how we connect the channel 1 and channel 2 into the input and output of the circuit. Based from the data table 1 that we recorded, we can see that when we increase the frequency, the voltage output will increase. It start with 100 Hz for the frequency, and we got the value for the voltage output, which is 917 millivolt. The last for the chosen frequency is 3000 Hz, which gives us value of 3 volt for the voltage output. Here you can see the table when we increase the frequency, the voltage output will also increase. It shows that the frequency is directly proportional to the voltage output. The value of the cut-off frequency that we get by doing calculation using 1 over 2 pi RC is 318 and 30 Hz, while by using simulation, we get 340 Hz. After that, a very common application of this type of passive filter is in audio amplifier as a coupling capacitor between two audio amplifier stage and in speaker system to direct the higher frequency signal to the smaller tweeter type of speaker while blocking the lower bass signal, or are also used as filter to reduce any lower frequency noise or rumbles type of distortion. When used like this in audio application, the high pass filter is sometimes called as low cut or bus cut filter, the cut of frequency. Okay, for the conclusion, we have seen that passive high pass filter is exact opposite to the low pass filter. This filter has no output voltage from DC 0 Hz up to a specific cut of frequency point. The frequency range below this cut-off frequency is generally known as stop band, while the frequency range above this cut-off point is generally known as the pass band. The cut-off frequency, corner frequency, or negative 3 dB point of a high-pass filter can be found using a standard formula of Fc equal to 1 over 2 pi Rc. Generally, the high-pass filter is less distortion than equivalent low-pass filter due to the higher operation frequency. Apart of that, we are able to determine the cut-off frequency for a high-pass filter circuit as well voltage output while using a sine value for our component. By using straight line approximation of the Bob plot, we also can determine the frequency response for the high-pass filter circuit. We also understood the high-pass filter only pass those signals their frequency are higher than cut-off frequency, thereby attenuating signal of the lower frequency. It has a response curve that extends down from the infinity to the cut-off frequency, where the output voltage amplitude is 1 over square 2 equal to 70.7% of the value Vmax or 93 dB 20 log Vout over Vin of the input value. That's all from me. Thank you.